Good morning, students. We'll continue the previous class. In that previous class, I was saying you about the thick lens. How refraction is going to take place through the thick lens. Okay, but here in this chapter, instead of going with a thick lens, we will be preferring thin lens. So this one only, what we discussed here in the previous class, that one only I just going to represent like this, just by imagining that lens as a thin one, very thin. Okay, yes. If it is thick, we have to consider double refraction. We have to make it thin and we go for only one refraction. You should know that if it is convex, then light ray is converging, I mean coming towards the principal axis. If a lens is concave, then that refracted light rays are moving away from the principal axis. That I show here now. Now look on this one. This one I have taken like this type. I taken a very thin lens. What we discussed here in this diagram, same I have represented. Just I have taken only one refraction. Here that was double refraction, bent inward, again bent inward. Here double refraction, but I have represented that here with only one refraction, like this, like this. Getting? Yes, here also this middle one was moving straight without any deviation. This lower, okay, it suffered two refraction, like this. Okay, that I even mentioned here with only one refraction. Okay, that we have to take when we being with a thin lens. Have you understood? I mean convex lens going to converge the refracted light rays. That's why we call that convex lens as a converging lens. Okay, I mean refracted light ray from a convex lens are actually going to meet at one point, so we call that point as a converging point and that lens we call as a converging lens. Yes. Now come across that biconcave lens. Here we show that incident beam after refraction by that concave lens was looking diverging. Those three incident light rays after refraction looking like this. They were diverging from each other. Why? See, look on that here. Again, that thin lens, I mean that lens we have to imagine with a thick lens. Okay, this one only I have drawn here by taking it as a thicker one. Again here we are going with the double refraction. Just imagine, okay, it's a biconcave lens. Now here one side there is an imaginary sphere, C1 is there, center of curvature, and here one more imaginary sphere is there, C2 is there, center of curvature. Now this line already I said we call as a principal axis. Now here in this also, O is an object, I mean point object placed on principal axis here. Okay. From that again we have to take three light rays as we see here. Three light rays. First light ray which already I have taken here. This is object. From that I have taken one this light ray. Okay. Say it again P. Okay. Q. P to Q. This PQ got incident here at this point. To that point, I mean that PQ is moving from rarer to denser again. To that Q point, you have to draw one normal. I mean, we have to join that Q point to the center of curvature of that imaginary sphere. Then that looks normal to that point. You extend that. This red dotted line indicating the normal to that incidence point. So now you see this PQ moving from rarer to denser. Then it has to bend towards the normal. You see here. Okay, this side normal belongs to incident light and inward this normal belongs to that refracted light. This incident light PQ, instead of going like this along this dotted line, it has to bend towards the normal. See here. This PQ, instead of going like this straight along that dotted line, it bent towards the normal. Red line is normal. This line bent towards the normal. Then you call this as a PQR. This point QR. QR bent towards the red line. I mean bent towards the normal because of its movement from rarer to denser. Have you understood? Yes. Now this QR got incident on another surface at R point. This is R. Now this light QR moving from denser medium to rarer medium. Again to that QR point you have to draw normal. To this incident point you have to draw normal, means you have to join that normal to the, you have to join that point to the center of curvature of that respective imaginary sphere. Okay, here sphere, their center point is here, just you join that point somewhere here. This is normal. Okay, this is normal line to this point. Now QR is incident. Okay, yes, it moving from denser to rarer. Then what has to happen here? Now here that light after refraction is going to bend away from the normal because it entered into rarer medium. That's why the speed got increased. I mean instead of going this QR, instead of going like this straight, it has to bend away from the normal. Where is normal? This red line is, this is normal. This is normal. Instead of this QR, instead of going along this dotted line, has to bend away from the normal. That's why it moved like this. It moved like this. You see this path. What happened here? P to Q. QR bent outward, and again thereafter RS, this we call as S. RS. This R also, R to S also bent away. Getting what I mean to say here? See, you can analyze here. You can see here. P to Q, Q to R, R to S. How it looking? That light ray is moving away from the principal axis. Getting what I mean to say? Then if you take this line, this one, this moves straight. Okay. Yes. If you take a light here, that also, how it looking? If you go with that analysis, that also keeps bending away from that one. I mean, try to see. That also bending away. Yes. Imagine. If you go with the laws of refraction here, what I explained here, according to that, if you go here, here also you will get that light ray keeps diverging. You see here, this light, this one and this one, how they look? These three incident light ray on that concave lens, after getting the refraction from that concave lens, they appears to diverging. They looking like diverging. They are diverging. I mean this concave lens is going to diverge those refracted light rays. That's why that concave lens we have to call as a diverging lens. Have you understood? Yes. This is thick lens. That only here we imagined as a thin one. Here you see here, it's a thin. Getting what I mean to say? If we consider thin lens, then there we are going to mention only one refraction. You see this line came and bent directly. One thing you should know, if it is a convex lens, then there will be a convergence going on. If it is a concave lens, then there will be a divergence going on. Have you understood? It's very important. Based on this, we called or we named those lenses as a converging lens and diverging lens. Yes, this is about the lens. Then I already told about the principal focus also. Yes, one more word is there. that principal focus we going to represent with capital F. Then one more word is there, it's very important, called as focal length, called as focal length, that we are going to represent with small f. The distance between the optical center and principal focus is called as focal length. The distance between the optical center and principal focus is called as focal length. I mean this from here to here. This distance we are going to represent with small f symbol. Small f is focal length, very important, focal length. Yes. Small f is focal length, capital F is principal focus. Have you understood? You will be getting question, 1 mark question on principal focus and even on focal length. Yes. After that, now we go with some important paths of light through a lens. Some important paths of light through a lens. Means what? A light, when it is going to incident on a lens, it may a convex or it may a concave. How it going to get refract? How it pass through that lens? That we are going to discuss here. Some important paths of light through lenses. First one, very important. Now you concentrate here on this one. I have written a parallel beam of light. A parallel beam of light after refraction. After refraction is going to pass through or appears to diverge from principal focus. What is this? See here. Look on these two diagrams. There convex lens there, here concave lens there. Here look on this one. This is one side surface. For that f dash I have taken as a principal focus point. And for this one I have taken f as a principal focus point. One thing you should know here, these principal focus points on both sides are at equidistant. I mean this O to F distance and O to F dash distance are equal. Getting what I mean to say? This principal focus point and this F dash principal focus point are at equidistant from the optical center of that respective lens. I mean O capital F is equal to O capital F dash. Have you understood? It's very important. While drawing the diagram also, you have to draw like that. This distance and this distance are looking like same. Okay? Yes. Now you see here a parallel beam of light after getting refraction is going to pass through the principal focus point. Look here. Here in convex lens, that line, that light ray, a light ray which is being parallel with respect to principal axis. This is principal axis. If a light coming parallel with respect to that, after refraction is going to pass through the principal focus point. Have you understood? If it is convex lens, then you pass that parallel ray of light through the principal focus. Through the principal focus. Yes. Now look here on this diagram. Here, this light ray is a parallel light ray, because this light is parallel with respect to principal axis. This light, after getting refraction from concave lens, obviously concave lens is going to diverge that beam. that concave lens is going to diverge that path. I mean, it is going away from the principal axis. Yes, this light ray, this parallel light ray, after refraction diverging in that way, it looks like coming from principal focus. I mean, a parallel beam of light after getting a refraction from concave lens, it is going to diverge and looking like coming from principal focus point. Have you understood? While drawing the diagrams called ray diagrams, we should be aware with these things. From where a light, if it is coming parallel and going to incident on convex lens, and after refraction, where it has to go, that light ray has to pass through the principal focus. Actually, it is going to pass through the principal focus. In case of convex lens, in case of concave lens, it appearing as a coming from principal focus. This divergent light looking like coming from principal focus. Getting? But there, that light is actually passing through the principal focus. Getting what I mean to say? That's why they are saying the principal focus point of convex lens is real. Mean what? Convex lens. Principal focus means what? Where those parallel light rays are going to meet. In case of convex lens, those parallel light rays are actually going to meet at that point. So this is existing point. This principal focus is really being. So the principal focus of convex lens is called as real one. I mean, at that point light rays are actually meeting. In case of concave lens, the principal focus point of concave lens is virtual, they say. Means what? The refracted light rays are looking like coming from one point, that we called as principal focus. Which kind of principal focus it is? It is virtual. These divergent light rays, these refracted light rays are looking like coming from that point. So it is virtual point. Have you understood? That's why one thing you should keep in your mind, the principal focus point of convex lens is real and the principal focus point of concave lens is virtual. Okay, it's alright. So now one thing you have to keep in your mind, it is very helpful while drawing the ray diagrams. In exam, they will be asking you to draw the ray diagram for 2 marks. That's why you have to be aware. Okay, yes, how those light rays are moving or they are getting refracting, you should know. If a light is parallel with respect to principal axis and going to incident on the convex lens, then after refraction you have to pass that light through its principal focus like this. Getting? Yes. If a light parallel with respect to principal axis going to incident on concave lens, then you have to diverge that light. You have to diverge that light in such a way that it is coming from principal focus point. You have to diverge. Yes, it came like this. Where you have to send? You have to send in such a way that it looks like coming from principal focus point. Have you understood? Yes, this is first path. Now look here. This is second path. Reverse of first one. What we imagined here in first one, the reverse it is. See that. Now, okay, a light ray, if it is coming from principal axis, a light ray coming from principal focus, not axis, a light ray coming from principal focus and going to incident on convex lens, after refraction, it moving parallel with respect to principal axis. Getting? If it is a convex lens and a light is coming from principal focus and thereafter refraction, it moving parallel with respect to principal axis. If we go with the laws of refraction, we are going to get it like that one only. Are you getting what I mean to say? This is not only imagination, it is existing point. If you go with the laws of refraction like this, what I have applied here, okay, if you go with a double refraction, then obviously a light which is coming from principal focus, after getting double refraction, it looks like moving parallel with respect to principal axis. Have you understood? This is in case of convex lens. In case of concave lens, what happening? A light ray, here a light coming from principal focus. In this one, a light ray which is going to meet, at principal focus. See here, a light ray which is looking like going to meet at principal focus. Look on this light. It is not coming from principal focus. What do you see here? This light ray, if you further extend, looking like going to meet at principal focus of that concave lens. A light which appears to meet at principal focus, after getting refraction from a biconcave lens, moves parallel with respect to the principal axis. Have you understood? If light coming like this, if we extend that further, looks like going to meet at principal focus, then that light ray is going to refract parallel with respect to principal axis. So now look on this third one. Okay, a light ray which is passing through the optical center of any lens. Okay, a light ray which is passing through the optical center, here also, which is passing through the optical center, will not get any deviation. A light ray which is passing through the optical center will keep its path continuously. It will not suffer any deviation. Have you understood? See, that gone straight on. Here also that gone straight on. Yes. Now fourth one. Look here. A light ray which is coming along the principal axis. A light ray which is coming along the principal axis means which incidence it will get? It will get normal incidence. A light which is coming along the principal axis and going to hit here means it going to get normal incidence. A light which gets a normal incidence, even that light will not suffer any deviation. It will keep moving along its initial path. Here this light also moving along that principal axis. Here also you can see the same thing. Okay, this is also normal incidence. A light ray which is coming along the principal axis will keep moving along that principal axis only. These four are very important paths of light through both convex and concave lens. With the help of these paths, now we are going to draw the ray diagrams to get the images of object placed at a different position in front of convex lens. Okay, I mean now we are going to get the image formation by the convex lens. It's very important. Already I said in exam they will be asking you to draw the ray diagram. They will ask you like that, okay, draw the ray diagram, okay, of an object placed beyond 2f in front of a biconvex lens. Are you getting? They will tell you to take a biconvex lens, and in front of that biconvex lens you have to keep that object beyond 2f point, and you have to get their image formation. They will tell you which lens you have to take and where you have to keep the object. This much they will tell. According to their question, you have to draw the diagram. It's very important. I mean, you should know perfectly how to draw the ray diagram. That is very important. Okay, now you see here. Now, yes, you look here. Many positions are there. I mean, in front of convex lens, where you will keep that object, that matters a lot. I mean, in front of that biconvex lens, where that object you will keep, that matters. Depends on the position of that object in front of that lens, it is going to produce the respective images. Already I said there are two kind of images, a real image and a virtual image. Real means that we are going to see and even we are going to get it on the screen. Okay, it is a practically or it is physically going to be there. Virtual means we can see, but physically it is not going to be present there. Look here, first one. Now, see here I have taken a convex lens. Okay. Now O is indicating their optical center point. Here I have written F dash. F dash is the principal focus point. This side somewhere at same distance, even we can take F. F for one side surface, F dash for another side surface. Both F and F dash are at same distance from the optical center. Alright. Now look here. I mentioned object is at infinity. Try to understand. When object is at infinity with respect to that biconvex lens, then where that lens is going to produce the image. Look here. In front of this biconvex lens, we have placed the object at infinity. From that infinite point object, we have taken three light rays. From that object which is at infinity, we have taken three light rays, and those three light rays are looking parallel with respect to each other. They are parallel with respect to each other. Obviously, when object is at infinity, then from that object light rays are moving in all directions. They are traveling a long distance. After traveling a long distance, we have to imagine them, they are parallel with respect to each other. That's why object is at infinity. These three light rays from that object are right now parallel with respect to each other. They got incident on that biconvex lens. Already I said, look on this first light ray. This is first light ray. It is parallel light ray. A parallel light ray, after getting refraction from the biconvex lens, going to pass through the principal focus point. This one light ray, yes, it passed like this. Look here. A parallel light, after getting refraction from convex lens, is going to pass through the principal focus. Yes, it passed already. Light. Yes. This one, this is second light. This second light ray is coming like this, and it got normal incidence and it got deviated without any change in their paths. Okay. Then third light ray. You look here. Third light. It came like this, and even this is looking parallel. After refraction, that also passing through the principal focus. I mean these three. See here, these three incident light rays, 1, 2, 3, they got incident on that biconvex lens, they got refracted, and all three got intersected here at this principal focus point. So already I said the intersection point of reflected or refracted light ray called as image formation point. Where those refracted light ray going to intersect, there they are going to produce the image. Are you getting what I mean to say? I mean the image of that object which is at infinity, here it got produced at this principal focus point. Have you understood? It's very important. Yes. Which kind of image it is? Those refracted light rays actually they got met. Actually they met means what? Their physical presence is there. I mean which image? It is real image. Real, inverted and highly diminished image. Getting what I mean to say? That point only is image. Means what? That is existing, that is physically being there. I mean it is real. Inverted means it is downward, I mean vertically oriented downward. Okay, real, inverted and highly diminished image is produced at principal focus point. Have you understood? Okay, yes, it's very important. When object is at infinity, then their image is going to produce at principal focus point. It's very important, you have to keep. Okay, even they may ask 1 mark question also, where image is going to produce when object placed at infinite distance in front of biconvex lens. At that time you have to say image is going to produce at principal focus point. If they ask nature, what is the nature of image produced? The nature means is real or virtual, you have to say. If it is real, then try to understand. If object is, I mean if image is real, then obviously it is going to be vertically downward. Where you will be writing word real, in front of that you have to mention real inverted. Real inverted. That may be a diminished or that may be a magnified. That going to depend on the position of object. Here later we will see with a different cases. Getting what I mean? Here what we can say finally, when object is at infinity, then image is going to produce at the principal focus.